Welcome to the Ducks Unlimited podcast, the only podcast about all things waterfowl. From hunting insights to science-based discussions about ducks, geese, and issues affecting waterfowl and wetlands conservation in North America, we bring the resource to you. The DU Podcast with your hosts, Chris Jennings and Dr. Mike Brazier.
Thanks for joining another episode of the DU Podcast. I'm joined here in studio by my co-host, Chris Jennings. Hey, Chris.
Hey, Mike.
And we're also joined on the phone all the way from California by our special guest on this episode, Mike Casaza, a research wildlife biologist with USGS, Western Ecological Research Center out in Dixon, California. Mike, thanks for taking the time to join the show.
It's absolutely my pleasure to be with you guys here this morning. Thanks, Mike and Chris, for having me on.
We have a really exciting topic, or basically a host of topics that I think we're going to touch on with this episode. We appreciate you joining us to discuss these, and it really centers on the use of radio telemetry to study waterfowl. And by judging from social media posts, I know this is going to be a topic of great interest to our listeners. Every year you see posts about someone having harvested a duck or goose that has a radio transmitter either attached or implanted, and invariably you see social media posts, the comments attached to that where people are asking about how it works or making some statement about how it works. And we as scientists that have worked with this technology, sometimes we chime in and explain it, but other times you want to, but then there's a whole host of questions that opens up. So the podcast here gives us an opportunity to explain a lot of this in detail that ordinarily we wouldn't really have a good venue to. And Mike, you're a great person to have on with this because you've done a great deal of work with radio telemetry, and you and your crew out in California are sort of at the forefront of some of the recent advancements in the telemetry being used to study waterfowl. So again, thank you for your time. And I want to start by giving you an opportunity to tell us a little bit about about who you are, your personal background and professional career, what you do out there.
Oh, thanks, Mike. Well, I started young out here and actually still working at the same research field station. We've changed agencies a few times, but I started out as an 18-year-old freshman at Davis, and my undergraduate advisor was Dennis Raveling, and he was kind of also known as Father Goose. A big man in the research world for waterfowl, and he hooked me up with the field station here, working on various waterfowl projects. I was a work study student, beginning my undergraduate at Davis, and basically have stayed here ever since, studying a whole bunch of different topics, and using telemetry as a tool to conduct a lot of the different research projects that I've worked on over the years. And I hate to date myself, but I think that started back in 1984 as a freshman at Davis, and I've just continued on that work and seen a lot of changes to the telemetry world and using telemetry as a tool.
Have you kept a tally of the number of birds that you've attached a transmitter to or implanted?
No, I imagine we could probably work that up, but if you're just counting birds, it's definitely in the thousands. It's probably tens of thousands. I've had the opportunity to mark other individuals. We've done a lot of work on giant garter snakes here in the valley too. They're a wetland dependent snake that's threatened here, and done telemetry on those, and a variety of different other bird species too, greater sage grouse out in the Great Basin. But yeah, no, thousands of birds and thousands of different types of telemetry, transmitters, different kinds, and it's really morphed over the years. And you mentioned the hunters now being, getting that prize and that social media post regarding, they harvest a bird with a transmitter. It's gotten a little bit more common because the price of some of these things has gone down to where we can get a lot more out and gather a lot more data. So the opportunity for the hunters to harvest them has kind of increased slightly in recent years.
How many transmitters are you putting on just on average out of your shop?
Just this last, we started about 5 years ago with a big push. The state of California is very interested in trying to understand how waterfowl are really gathering the food resources they need here. And so we've been putting the last few years, we've been putting probably about an average of about 150 of these GPS GSM transmitters on various species of waterfowl. And that's kind of gone up. We added some goose work the last 2 years, so it probably puts us up closer to 200 transmitters. And each one of these, we can maybe talk a little bit about it later, but the cost of these is still pretty high with these GSM GPS transmitters. So you're limited in how many you can put out by how much funding you can push towards the projects.
I bet it is very difficult to put a band on a garter snake.
Yeah, they kept coming off. That's a funny story, and it's funny that you say that, because we actually published a paper on using some tape to actually tape external transmitters on snakes, and they basically kind of drug the transmitter around. It worked okay. It had a limited reliability, but for certain questions you could do that. It was kind of like an interesting attachment technique. The one that really works is implanting them surgically, but we did try almost like a band.
Very cool. So. Very cool.
Mike, let's. What I'd like to do on this first episode here is get you to talk about the evolution of telemetry. That's one of the fascinating things to me. I certainly wasn't around whenever telemetry first hit the scene, but and I don't think you were either. My notes say it began somewhere in the 1950s. But I guess before we do that, why the need to study individual birds? What does this give us at a fundamental level that we don't get from other types of studies?
Yeah, so the transmitter, the telemetry, transmitter as a tool, it gives you the ability to track where an animal moves and the types of habitats it uses and the fate that we have a known fate for that individual. We can track it until something happens till it dies, or for a certain period we'll know everything it's doing, and so it gives you an insight, an inference to the population that you can't get without doing something along these lines. So we're basically able to infer. We make the assumption that if we mark enough individuals, we're actually being able to chart what the population of animals are undergoing, and what their survival's like, what their the habitats they're using. Just answer a whole bunch of questions about the population, but base it on the individual and gather that data from the individually marked animal.
We've had an episode or two recently where we've mentioned this idea of individual heterogeneity. I believe it was Drew Fowler in the episode about body condition bias in geese harvested over decoys, and the telemetry really brings that home whenever you start talking about how individuals vary. And you, and the work that you're able to do with telemetry, you're monitoring those individual birds, tracking them, and assessing their fate as you described. And then you can relate all that back to how those individuals vary in response to certain characteristics. So just a connection back to some of the other episodes we've had here. And so now let's talk about briefly the evolution of telemetry. When did it start, and then what have we seen through the years to take us to where we are right now?
Yeah, the original telemetry work that I worked on back in the 80s, and some of the stuff that was pioneered by like one of our station leader at the time when I started, Dave Gilmer, had done a bunch of work in the Dakotas and Minnesota using VHF telemetry, very high frequency telemetry, which is really it's a radio signal. The transmitter puts out a beeping sound when you listen to it through a receiver, and you have a handheld or a vehicle or airplane, in Dave's case, mounted antenna that picks up that signal, and you can triangulate where that animal is, where that transmitter is, by going to various locations and getting your best bearing and putting those signals together and getting a location, which all that required a tremendous amount of manual labor and time. And so if you were lucky, you could get a location on, say, an individual animal once or twice a day. And if you had several marked, if you were lucky to get 10 or 12 individuals located in a given day.
It also requires a lot of trigonometry
It does. There's a little, a little trig involved, cosines and sines and angles, and you had a lot of error back then too, in terms of how well you could get your signal, how far away you were, what your angles were. So the error in that VHF telemetry data set was pretty high. You had low sample size because it was hard to track, and then you had relatively high error, like at least hundreds of meters of error in your location. And then that was with the individually tracked VHF transmitters, and now that's kind of evolved over time, and we went to satellite-based transmitters that offered a more precise location, but not at the GPS level. It was or actually maybe not even more precise, but you wouldn't have to go track the birds. They sent the signal of where the transmitter is through the satellites network.
And then that would be downloaded to you. That was one of the key advantages there. This is that Argos, is the Argos satellite system?
Exactly. Yes, the Argos system, and so your locations have they're the amount of power that the transmitter takes to send that signal through the satellite is pretty significant. So the transmitters tend to be pretty large, and the number of locations you get again is relatively small because it takes so much power to send that signal. And then the location quality of those Argos data, somewhere around 300 meters is usually about the best you're going to get with the Argos PTT data, and then. Now we've evolved all the way to the getting GPS signals through the Argos system as well, and you can get those, which obviously GPS have an error of about 5 to 10 meters, and then on up to the transmitters that we're using now, the GPS GSM transmitters, which actually use the cell phone network to transmit the data. So, and that's the ones that we're primarily using right now, and it's essentially sending a text message with the locational data and other sensor data from the transmitter to us, and we just download the data, and we're getting data, and you can get data up to every minute, depending on how your battery's doing for your transmitter.
How big are some of these transmitters? I mean, and do you have different sizes? Like, do you have different size transmitters for green-winged teal rather than a mallard?
Absolutely, yeah. And that's kind of been the limiting factor all along. It's just the size and weight. It determines how many locations you can get, what the quality is. As scientists, we go through the process of figuring out, what's the best transmitter we can put on to answer the questions we want to answer for a given species based on the limitations of the manufacturers. So, we're putting on 10-gram GSM GPS transmitters on green-winged teal and cinnamon teal, blue-winged teal right now. And they're, collecting data, pretty reliably. They're solar powered, and depending on the sun, we're getting data, as often as every 15 minutes, GPS quality data on those.
Somewhere down the line, someone had put a large transmitter on a smaller duck and was like, uh-oh, that's not going to work. So, that lesson had to be learned somewhere.
Yeah, and we've pushed the limit on that, and we can get special permission to try things out from the banding lab, but the basic rule of thumb is, you try and be less than 3%, with exceptions up to maybe 5% of the average body weight of the individual being marked.
Early on in the use of radio telemetry, there were a host of studies that mainly they were captive studies that used they were trying to investigate the effects on the behavior and survival and related to the size of the transmitter, the method of attachment. So the amount of study, the amount of work that's gone into figuring out how to do what's the best attachment, what's the most appropriate side. It's pretty phenomenal in its own regard, and we still haven't gotten that perfected. Anytime you attach something to a free-ranging animal, there's going to be some effect. The idea is just to minimize that as much as possible. And so, Mike, have y'all done some of that work with these new GPS GSM transmitters?
Yeah, and it's a great point is, every species and even to some extent individual reacts a little bit differently to having a transmitter attached to them. Obviously, it's going to, there's no real way to have no effect. But we've looked, pretty intently at trying to figure out ways to minimize those effects. One of the things that we did when we first started, we were using a Teflon harness that really had no stretch to it. It was good about not really absorbing any water into the harness, but it had really no stretch to it. So the birds, their body size can vary quite dramatically over the course of a annual season. And so we found some automotive nylon that we had custom made to attach the transmitters with, and it has pretty significant amount of stretch to it, and it doesn't really have any memory. So the material will stretch as the bird gains weight or loses weight, as the case may be, and then we've recovered some of those transmitters after being deployed for a couple of years, and the material still seems pretty vibrant. It still has that stretch to it, hasn't lost that, and I think we're pretty happy with that, as in terms of at least reducing some of the stress of having that backpack attached to the various waterfowl species.
Yeah, what you just kind of alluded to it, of when you're retrieving these transmitters. What are some of the oddest places that you've found some of these transmitters where you've had to go and get it, and you're like, well, why would this thing be here?
Yeah, we've had over the course of the many years, not just in our recent work, but we've retrieved some from freezers where we tracked them into freezers that maybe were placed there out of season. We've had a few where we had to have the game wardens go and retrieve them from some poachers, all the way to we recently had one picked up on the top of a building just outside of Reno, that a Raptor had obviously carried our cinnamon teal up there and dispatched of the teal and left the transmitter sitting on the sun on the roof, which allowed us to find it pretty readily. So, yeah, we've had over the years, there's been a lot of different spots where a lot of treetops, eagles' nests, hawk nests. We have one sitting on the top of a bridge in the Bay Area right now that we were still kind of figuring out how we could see if we could talk to the Caltrans and see if we can get that recovered.
The Ducks Unlimited Expo, May 15th, 16th, and 17th, 2020 at the Texas Motor Speedway in Fort Worth, Texas. Interactive villages, shooting, archery, dogs, fishing, kayak, canoe, 4x4 off-road tracks, ATV, UTV track, industry experts, demonstrations, exhibitors, and more. The Ducks Unlimited Expo, everything outdoors. The ultimate playground for the outdoor enthusiast. The Ducks Unlimited Expo. Visit www.duckexpo.com.
It's pretty interesting. You talk to anyone that's worked with telemetry, and they will tell you of some pretty fascinating stories. When I was actually out in the Central Valley of California as a research technician working for a graduate student, and we were radio marking ducklings, mallard ducklings. They have these little small, 3-gram transmitters. Would that be about what they would be, Mike? That the little prong and suture, 3-gram, 2.5?
2 to 3 gram prong and suture VHF.
Yeah, so the VHF.
So you'd had to track them with your handheld antenna. That's a lot of work.
That's right. Track them with a handheld antenna, as well as the big mast that protrudes up through the roof of a truck, and you drive around and people think that you're like listening for aliens or something, or you're eavesdropping on their telephone conversation. That's the most common thing. But I had a couple of instances where I retrieved a duckling carcass from a bullfrog, because you could still get the signal. You could see it coming from the water, and so I was actually able to retrieve a bullfrog. And then the other one was I saw a coyote running across the field, and as the coyote ran, the signal followed the coyote, and it slowly began to become fainter and fainter. So you get stories like that. It's really neat because you see those processes in action when you're able to track the individual birds there. Mike, talk to us a little bit about because this is another one of the posts that I see often. People are wondering what are the capabilities of these transmitters. What kind of sensors do we have in them? Do we have are we able to incorporate in them?
Yeah, so the new sensors, it's really exciting. and we are actually working with NASA on a project to try and develop ways to add even more sensors to the transmitters. But right now, we have you have an altimeter. You can get the altitude. You can get the temperature. You have temperature sensors. You have accelerometers, which are similar to like what you find in your Fitbits or your Apple Watch or whatever, where you can get activity levels, and it basically records like the different planes, again back to geometry, but the how the transmitter is moving, and it records that, and it can record many data points per second, and we can get an idea of when the bird's flying, when it's feeding, tipping, resting. And so, in the transmitters themselves, the ones that we're using store all that information on board, and when they're in good cell phone range, they will download that data through the cell phone network, and we can gather up all that data and have all kinds of information beyond just where the bird is, but actually, what it's doing, how it's spending its time, how much time it's flying, things like that.
And you have the ability to customize these transmitters. It's not as though you just have a limited menu from which to choose. You can go in and customize this. You can choose the size. You can choose the different sensors. You can choose the frequency with which they're collecting the data, transmitting the data. So it's not as though every transmitter that's out there is of the same type. That's the other great thing about it, is you can customize these to maximize the relevance of the data for your particular study objective.
We can, just basically customize it to the research question. So if we're really interested in, the time activity budget of a bird, we're interested in making sure we have enough habitat on the ground to feed these birds over winter, say. We can look at their activity budgets and use the accelerometry data for that and set those to record, that data accordingly. Or we could, if we're interested in another question, maybe mortality, we're looking at the activity to just see, when a bird dies, and then try and figure out what occurred there. So there, and then the other thing that's really kind of great is most of these transmitters are solar powered, so we can adjust how much data they're collecting based on the battery level. So when they are fully charged and we're doing good with power, we can try and gather as much data as possible. So we're not just sort of preset to what to one setting type. And they're interactive. So every time they can interact with a cell phone network, we can go in and change the settings. And so we can do that on a daily basis, even hourly. If we need to.
Would you say that's been one of the most significant advancements, is the ability to actually communicate with the device while it's deployed?
Yeah, that's really allowed us to attack different questions at different times. Like, for instance, one of the questions we were having was, how does disturbance affect waterfowl? And so one of the things we wanted to do to look at that was to really get a good pulse. So we wanted to see, what individual birds were doing every 2 minutes. And so we were able to manipulate those settings and kind of store up some battery power for a week or two, and then pulse the transmitter. So for 24 hours, we were able to get locational data every 2 minutes on a group of pintail and mallard. And so we can really get that fine scale look at how they're moving through the environment, what's going on every other minute, and just get a tremendous amount of data to answer these really kind of specific, really interesting questions on how a bird spends its day that we haven't really had any ability to do before. So, and that's just one example of being able to manipulate those settings remotely from our office, and push the transmitters to answer these really cool questions.
Hey, Mike, what would a hunter do, if they harvest a transmitter? There's always some discussions of this. Some people are under the impression that they're going to get, in trouble, or someone's going to be upset. But if a hunter harvests a bird with one of your transmitters, what's that process for them, and how do you guys handle it as well?
Yeah, that's, we look at it, anytime a hunter harvests one of our birds, we're excited about that. We're happy for them and then happy for us at the same time. And I say that because a lot of times, they'll harvest a bird that maybe had a transmitter that was placed on it a couple years ago. Maybe it's not working anymore. And so that's great data for us. And if we just encourage them highly to contact us. We have phone number on the transmitter itself, website, so email address as well. And, getting that data, the opportunity to get that data for us is just really exciting. And what we try and do too is, because we know it's kind of it's a special event for the hunter, something that doesn't happen every day, and so we try and make sure that we communicate with them, get information from them regarding the bird, and then in turn we share really detailed information about the bird that they harvested, with them, and we'll send them like a full-size poster with all the bird's movements, and if the bird's been marked for a few years, it can be a really interesting poster of their bird's movements. And then we'll also send a dummy transmitter, one that looks exactly like the transmitter that they harvested, maybe minus a little wear and tear. That if they want to mount it on their bird, that they would have that, and then that way we could get the working transmitter back and hopefully deploy it on another bird and get even more information.
Is there data that you're getting from the transmitter that wasn't sent to you? Like, I'm just assuming in some, in a matter of power saving, maybe you're not sending all the data all the time. Maybe there's something on that transmitter that when you guys get it, it's unique to being harvested. Is there anything like that?
No, there is. Yeah. I mean, and that's it's sort of like, it's finding a treasure at some level. I mean, some of the transmitters, if they're in good cell range, they're giving us the data, pretty much daily. But some of these transmitters, maybe like on a pintail, it might be have spent its summer, up on the north coast of, north slope of Alaska, and then gets back down into Alberta and maybe gets harvested there, and hasn't had time to hook up with the cell phone network and download its data. So, and it may never, because sometimes, they lose their ability to charge after a few years, and we're not able to get that data. So sometimes it's still stored on the memory chip in the transmitter. So we can get that data. We send the transmitters back to the manufacturer, and we've downloaded a lot of data from these hunter return transmitters. It's been invaluable for us. And
the point that can't be emphasized enough is that the hunters will not get in trouble for harvesting one of these. They haven't killed some top secret bird. They haven't ruined a research study. They don't need to remain secret. It's totally the opposite. They're not going to get in trouble. They are to be commended for their efforts. And like you said, Mike, it's somewhat of a trophy. And all the researchers that I'm aware of that are involved in these studies do something very similar, if not identical, to what you do. They provide as much information to the hunter as they possibly can. They will provide a dummy transmitter. They want the hunter to feel like they're an active part of that research, and they give all that stuff in exchange for, or to say thank you for calling that in, and for returning the transmitter, as you said, because these aren't cheap when you start talking about accelerometers, altimeters, GPS, GSM. They're not cheap, and so by returning that transmitter, they become an even more important part of active waterfowl research. In many respects, it's the equivalent of donating the value of that transmitter when you call and return it. So.
And I bet the Raptors are much more efficient at killing ducks with transmitters than hunters, for sure.
Yeah, well, they are pretty good at it. I'll give them some credit, and that's one of the other things. It's an interesting point about Raptors is in the transmitters themselves. And when we ban birds with bands, most of our returns, or almost all the returns on band returns, are from hunters. When we mark birds with transmitters, we're getting returns from hunters, which is great, and we're also getting those returns. We're figuring out, what else is taking these birds out in the wild. Is it a disease outbreak at a refuge somewhere? Is it botulism? Is it a raptor? And so the known fate, the ability to figure out what's going on beyond just hunter harvest is a really great thing from the learning and understanding aspect of using these telemetry tools to figure that out.
Yeah, and I'm just curious, how do you notice that, like, when a bird has died in some way, shape, or form? Do you, like, if that thing is sending the signal, can you look at that data and just be like, oh man, we got to go get this one?
Yeah, absolutely. Yeah, the new transmitters make it really easy, and in some sense, the old ones did too. You just had to be within a mile of them to know they were dead. And the old transmitters, the VHF ones, they would double the pulse rate. And so if you heard it beeping twice as fast as normal, you knew that bird hadn't moved for 8 hours.
There's a mercury switch, right? It would either be thermistor, a little temperature sensor, or a mercury switch, right?
Yeah.
That was the old way. And now with the accelerometer data, we actually, we have alerts when the data comes in. We can know a bird's dead within, depending on the frequency of the relocations, within a few minutes of it dying. And so, and we can, basically you could tell we've marked some rails with these, that are in a tidal environment, and we can look and see, was the tide high or low when this bird, was eaten by a predator. And so we can look at things like that we've never been able to really like pinpoint, maybe what day or maybe what week it died, but now we actually know pretty much down to the minute. And the accelerometry data really can help with that. It pretty much just goes flatline. So it's not, you don't have to be a great scientist to figure out when they're dead. You just need the data.
Speaking of mortality, Mike, am I correct in thinking that for our typical banding analyses, survival estimation from banding analyses, these transmitted birds are typically excluded from those analyses? I can imagine some hunters wondering about these being incorporated into those analyses. But I know transmitted birds are sometimes used to specifically answer a question about within season survival. But when we don't, these transmitted birds generally are not lumped in with the larger population of banded birds for those analyses, are they?
No, that's, because obviously we talked a little bit. We realize that the transmitter is going to have some effect, and some, maybe more in terms of some birds than others. So the banding lab, when every bird gets banded, it gets a special code that gets input. So when we band a duck and then put a transmitter on it, it gets a specific code that lets the banding lab know that it has a transmitter on it. And then, so when those banding analyses are done, they're primarily just done on birds that have that, just the standard code, no transmitter, nothing extra. And that's what those types of survival analysis will be done on.
And another point worth making here with respect to a hunter harvesting one of these birds, we're asking them to do two things. We're asking them to report that aluminum leg band as they normally would to the bird banding lab, but then also to contact the researcher that's been responsible for implanting or attaching this transmitter to that bird. And usually that information is either is included on a separate leg band, or it may be on the transmitter itself. Right, Mike?
Yeah, that's correct. And usually we'll get a call. A lot of times they'll call us first. It doesn't really matter what order. I think, definitely you need to report that band, and they'll get their certificate from the banding lab. And then if they don't contact us, the banding lab sends us a report too. Sometimes the phone number's worn out and can't really read it. And so the band is usually the solid marker. So as long as they report the band and they report their contact info, we'll get back to them. We'll either email or call if they provide their number, and then they can provide really a wealth of information about the bird itself. Was it flying by itself? Was it flying, in a flock? How'd the bird look? What's the condition of it? Was it fat? Was it, in poor condition? And we can use that information, and we have to really get a better feel for, is our attachment, radio transmitter attachment type working correctly? Are we hearing of any, issues like, the bird swam into my decoy? So that would be a bad sign, right? So if we get any kind of responses like that, which we really rarely do, but that really helps us to kind of get a feel for how the attachment methods are working, and that information is invaluable, because those are observations made in the field by the hunter, the collecting the bird, can really, let us know if things are going well or if we may have an issue with something.
Mike, I know you're involved with a host of telemetry studies, investigating a host of research questions, I should say, and we want to talk with you about a couple of those things, but I believe we've probably covered quite a bit of ground on this episode, and I think this is probably a good place to wrap this one up. Thanks so much for your time on this episode and for sharing a wealth of information. And I know, like I said, this is a topic of always of great interest to our to waterfowl hunters and our supporters. So thanks for your time.
Oh, my pleasure.
A special thanks to our special guest on this episode, Mike Katsatsa with USGS, Western Ecological Research Station. Also thank my co-host, Chris Jennings. And as always, we thank our producer, Clay Baird, who does a great job getting these podcasts out to you, our listeners. And of course, to our listeners, y'all are the most important part of this venture. We appreciate you spending your time with us. Thank you for your commitment to wetlands and waterfowl conservation.
Thank you for listening to this episode of the DU Podcast. Be sure to rate, review, and subscribe to the show, and visit www.ducks.org/DU Podcast for resources based on today's topics, as well as access to more episodes. Opinions expressed by guests do not necessarily reflect those of Ducks Unlimited. Until next time, stay tuned to the Ducks.